welcome everyone. So in today's class we will talk about discrete time convolution in MATLAB. So so far we have discussed the properties of systems, and in the previous lecture we discussed the linearity and time invariancy property of systems. Systems that are both linear and time invariant are called linear time invariant systems, and there will always be a lot of talk about linear time invariant systems because they are very important systems. They can be used to model many physical processes, and they provide a set of properties and powerful tools that form the core of signal and system. So LTI systems and signal and system are very important. The fundamental result in LTI system theory is that any LTI system can be characterized entirely by a single function called system's impulse response. So the impulse signal is very important in LTI systems, in LTI systems, and in signal and system also. The output of the system is the convolution of the input to the system with the system's impulse response. The system's impulse response is also called the system function. Coming slides will discuss these points more thoroughly. So if we have an input signal which is x of t, continuous time input signal, or we have a discrete time input signal which is x of n, and that is fed to an LTI system whose impulse response is h of t or h of n, we can obtain the output of the signal y of t or y of n by doing convolution of this input signal with this impulse response of the signal. Fine, and this impulse response of the signal is also called system function. So if you perform convolution of x of t and h of t, we get y of t. And discrete time, if we perform convolution of x of n and h of n, we get y of n. So the convolution is basically used to find the output of the system by convolving the input and the impulse response of the system. So if the input to the LTI system is unit impulse response, the output is impulse. If the input to the LTI system is unit impulse signal, the output is impulse response. So the system's response or the system function or the impulse response can be found out by feeding an input signal which is impulse function to the system. So if we feed an impulse signal to the system, the output will be the impulse response of that system. So convolution is actually a mathematical operation, just like you perform addition, subtraction, multiplication, division. But convolution, addition, subtraction, multiplication is performed on two operators. It's performed of two operands. Similarly, convolution is performed on system function, which is impulse response and input signal. So the convolution of input signal and the impulse response of the system gives us the output of the system. Now to perform discrete time convolution, again we have three different types of methods. We have graphical method, we have analytical method. The third method is the matrix method or tabular method. It is also called tabular method. It is also called matrix method. This is the simplest of all the methods. So I am going to perform convolution on this method. So if we have an input signal which is delta of n plus 2, delta of n minus 2, which can be written as 1, 0, 2. At n is equal to 0 it is 1, and at n is equal to 1 it is 0, and n is equal to 2 it is 2, 1, 0, 2. Fine. Then we have the impulse response of the signal or the system function, which is delta of n minus delta of n minus 1. It can be written like this, 1 of minus 1. So how can we find the output? The output can be obtained by performing convolution of x of n and h of n. So by matrix method, how can we perform convolution? We will write x of n here, we will write h of n here. Fine. Now this one is multiplied with this whole row. So we have 1, 0, 2. After this is multiplied, I will shift by 1 unit to the right. So after shifting to the right, I will multiply this minus 1 with this 1, 0, 2. We get minus 1, 0 and minus 2. Finally, what we will do is we will add all those. So 1 will come here, 0 minus 1 is minus 1, 2 plus 0 is 2, and minus 2 will come here. Fine. And this is our n is equal to 0. So we have delta of n minus, this is minus 1, so we have minus here, delta of n minus 1, 2 here, n minus 2, and minus 2, which is delta of n minus 3. As you can have a look that the sum of the elements in the output after performing convolution is 4. Here we have 3 in the input and we have 2 in the system function. So the total number of elements in the output will be this input plus impulse response, number of elements in input plus number of elements in impulse response minus 1. So 3 plus 2 minus 1. So if we name it this n and this as m, so the number of elements here will be n plus m minus 1. Fine. The number of elements in output after convolution will be equal to the sum of the elements in input and impulse response minus 1. As you can have a look, there we have 4 elements. Now how we will perform this in MATLAB? I have assigned x vector, which is my input. I have assigned h vector, which is the impulse response as the system function. The command used in MATLAB is conv. So this will convolve my input signal and my impulse response signal. So I will subplot stem x because I am using discrete time, and I will title it as input signal. So this is plotted, which is x is plotted here in the subplot 311. Then we have the impulse response signal plotted in the 312, and then finally we have this convolution signal plotted as the output signal. Remember that MATLAB always starts from n is equal to 1. It can never start from n is equal to 0. I mentioned it earlier. So assume that 1 is 0. So let us perform this in MATLAB.